Lesson 19.4, Task 3. Compare real-world quadratic functions. A marching band drum major practices throwing her baton into the air. During 2 practice throws, she does not catch the baton and it lands on the ground. The height in feet of her baton after t seconds during her first throw is modeled by the graph of the quadratic function h1. A description of the height h2 of the baton during the second throw appears below the graph of the height of the first baton. All right, so here's the graph of the first missed throw. So you can see it starts at 0.5, so it's starting at 5 feet. It goes up the vertex, the highest point is at 1.5 seconds and 41 feet high. So the highest point is 41 feet after 1.5 seconds. And then it comes back down and hits the ground just after 3 seconds. All right, so the second missed throw, which reaches a maximum height of 22 feet and 1 second. Which throw has a greater initial height? That means beginning height. We know this one's 5 feet, and we have to find out what it is for the second one. After how many seconds is the baton at the same height during the 2 missed throws? Find the initial height of each missed throw. Using the description of the second missed throw to write a model in vertex form, then simplify and rewrite in standard form to identify the initial height. All right, so this shows you why it's important to be able to go back and forth between different forms, vertex form, standard form, and intercept form are all good forms, but they're all used for different things. All right, so we were given 1 and 22. That was given from our information above here, 22 feet in 1 second. And we're just going to plug it into our general formula here. So our second height is modeled by h2 of t. So our height in time is negative 16 times t minus 1 squared plus 22. Once I have this in vertex form, I need to expand that and put it in standard form. So multiply, expand the binomial squared. So do t minus 1 times t minus 1. If you remember that formula, that's great. It's going to be first term squared minus 2 first and last term, and then plus the last term squared. And then you've got to multiply that by negative 16 and then add the 22. So basically take this function in vertex form, expand it, combine like terms, and put it in standard form. This is standard form, a x squared plus bx plus c, where a is your quadratic term, b is your linear term, and c is your constant term. All right, so the initial height of the second missed throw is 6 seconds. Remember, the initial height, or the y-intercept, comes from the constant term when it's in standard form. So that initial height is 6 feet. The graph of the first missed throw shows an initial height of 5 feet, and that comes by looking at the graph. If you look at the graph, you can see that it started at 0.5, and that's how you know the initial height there. So the second throw has a greater initial height of 6 because 6 is greater than 5. How do you know the initial height is 5 feet? Select the correct word or value to complete the sentence. The blank of the graph of the function, the y-intercept of the graph of the function is 5, and the y-intercept is the initial height. Okay, and that came from the graph above again. So you can see it was the y-intercept. This is the y-interceptor is on the y-axis right there. 0.5 is your initial height. All right, for the value of t, for which h of 1 of t equals h2 of t. So that means find out when the two functions intersect. When are they equal? At what time, after how much time occurs, are these two functions equal? So use the graph to find a projectile motion model for the first throw. So you're going to use h of 1 of t, again, the same function that we've seen through a couple, 2 or 3 lessons now, and you're going to just plug in your information. So use the 0.35 on the graph to find the value of v of 0. So if you go back up, you can see that this is a point on the graph. So we're going to use this point here to plug in to write an equation. All right, so this is after t is 3 seconds, because your ordered pair 3, 5. Remember, the first number is your time, t in seconds for this case, and this is your y value, or your h of t in this case. So we're plugging the 3 in here and the 5 in here, and that allows us to solve for the only variable left, which is v sub 0. So we're going to solve that. Just simplify these and combine like terms, and you're going to get v sub 0 equals 48. All right, so it says, why can't the 0.05 be used to find the value of v sub 0? Select the correct number to compare each sentence. All right, so when you look up here, you have 2 points here that we could use, 0.5 or 3.5. They're saying, why can we not use this? Okay, so if times 0 is plugged in, what happens when you multiply by 0? All right, so the 0.05 has a t value of 0 in the function. If 0 is substituted for t in the function, then the term v sub o of t would be equal to 0, because 0 times anything equals 0. That means you cannot solve for v sub 0. So you cannot use this point just because your x value is 0 there. So you have to use the other point given. All right, so h of t equals negative 16t squared plus 48 is the number we just found for v sub 0. So plus 48t plus 5. So set this equation equal to h2 of t and solve for t. So we're setting h1 and h2 equal, and we're just trying to find out when the time is equal to each other. So this says 16t equals 1. Divide both sides by 16. After time is 0.0625, so it's a fraction of a second. So it says the baton is at the same height, exactly 0.0625 seconds into the 2 missed throws. So that's very exact number there. All right, so how can you use a graph to obtain this result? All right, we could graph these two functions, h of 1 and h of 2, and you find the intersection point, and the intersection point is also going to be at this same time. So here we did it algebraically, set the two equations equal. You can see that the t squareds cancel. If you subtract 32 from both sides, that leaves the 16t, and subtract 5 from both sides, that leaves the 1. So this was done algebraically, but you could also graph h1 and graph h2, and where they intersect, the x coordinate of the intersection point would be at this exact height as well. All right, that is all for task 3. If you have any questions, let me know.